Tutorial number 3, 4-axis cutting. In this tutorial we'll show you how we can create a 4-axis shape for the Wire EDM system by creating contours which have different shapes, top and bottom. So I'm in the CAD system, so what I'll do is I'll create just a couple of polygons to show you the concept. So let's have a 5-sided shape based on a circle diameter of 75 millimeters, and in near snap I'll snap that onto the center point. Now we'll create another polygon which might have 8 sides based on a circle diameter of 100 millimeters. Right, so those are the two shapes that I'm looking at. What I've got to do is decide about where I want a start point for these two shapes. So if I created the contour which was the smaller one, which is going to be at the top, I've got a logical starting position which is that position there. But on my bottom contour, then what I need is a corresponding start position which is going to be in close proximity to the start position of the top contour. So what I'll need to do is I need to break this line down at the top at its midpoint. So to do that I use intersect, midpoint split, and what that will do is I indicate the line, and that now creates two line segments for me. So when I'm creating my contours, I can use the start point here for the top shape and a start point here for the bottom shape. So I create my contours, NC, contour, start point. Is the shape closed? Yes, it is. I don't need to worry about the depths because I'm going to tell the Wire EDM software how far apart these two contours are. So from my start point, which is indicated by the red dot there, I want it to follow this line first. Now I'm still in NC contour mode, so I can carry on and create the contour for the other shape. That's the start point, and I want it to follow that line there. So having got to that, I can now save that drawing away. And then link through to the Wire EDM software. Machining, Wire EDM module. So we're now in the Wire EDM system. I don't need to do anything particular with the Z heights and so on because I'm going to come on to that in a moment. Right, so what you can see here is, as a default, what happens is that the system creates a go-round command for the number of contours that it finds. So it's found two contours and it's generated two go-round statements. But in effect I don't need both of those. So what I do is I just click on the one and press the delete key, and that will now delete out that operation. So I've now got a single go-round command, and within there I'll tell it the programming mode is a double contour with X and Y and U V paths both defined. So the geometry for my XY shape, it needs me to enter the depth. So that's the contour for the bottom, contour for the top is that one. I'm cutting forward and I'm going to offset to the right. So when I run that job, it's now created a path starting from the center and uses the bottom shape as the XY path and the top shape is the UV path. So that's how simple it is to create a 4-axis shape by defining two separate contours within the CAD system and creating in the Wire EDM system a double contour mode using geometry for the XY plane, the UV plane, and giving the system a thickness between them. Now, all the other things that we have looked at previously to do with roughing and finishing passes and so on can also be applied to a 4-axis shape, although you've got to be careful to make sure that the slug that you're going to be creating can physically be removed from the job. So that's how the 4-axis shape is created. And on a regular shape like this, it's pretty easy to see where the synchronization points are between the wire. But what we can do on this shape and on more complicated shapes it would be particularly necessary is to add synchronization points so that we can force the system to create synchronization points where we want them to be. And to do that we use the synchronization point here. So we need to confirm where the XY and UV contours are, and now we can move the mouse around so it always works on the bottom contour first. Notice that I can't lock onto the top contour because I need to do the bottom contour first, so I give it that point and then I move my mouse to the synchronization point there. And I could do the same thing here, to there, here, to there, and here, to there. And then when I'm finished with that, I simply simulate the job, and now you can see what's happened. I've forced synchronization points between the bottom and the top contour at these positions. Now, because of the nature of adding synchronization points, if I need to change any of those, I have to redefine all of them. And that's because if I tried to just pick up certain points, then the system wouldn't be able to calculate accurately where the synchronization points needed to be. So if I want to change the synchronization points, it's simply a question of going through that same routine and changing synchronization points. For instance, what I could do is I could synchronize from the bottom contour there to that point, and also synchronize from that point to that point. Now when I run that job, you can see how I've got movement between those two positions in X and Y, but with no movement in the UV axis because both points have been synchronized to here on the top shape, on the UV shape. But you'll notice how, having done that, it's thrown out of synchronization all the other positions around here. So if I need to change that, it's simply a question of going back through and doing a similar thing on the opposite side. And now we've got the same situation on the right hand side and the left hand side. So that's how easy it is to create a 4-axis shape and to change the default synchronization points to a user-defined method using the Edit Sync Points command from the main toolbar. When you come to post-process that, of course, what you'll end up with depends on your machine tool and the post-processor, of course, but in general you're going to get XY and UV commands which will produce that shape. That ends this tutorial concerning 4-axis cutting.